Greetings to you all. Welcome to Grade 8 Theta. And today we are going to look at matrices and the quantitative methods. And so when we say matrices, what does it mean? We have the word matrix, right? So this represents or this is the singular form of the matrices. This is the plural. And so what's the function, or why do we then use matrix? Okay, the reason is, assuming you have two shops. So suppose you have shop A, you have shop B. Okay, and these two shops, you are going to look at the number of sales, or the sales that they made in, let's say, the previous week. Okay, so a product, sugar, you can say sugar and salt. Okay, so shop A made a sale of 1,000 for sugar last week and 3,000 cedis for salt. Okay, right, that is last week. And this week, I'm sorry, the same last week, shop B made a sale of let's say 5,000 Ghana cedis for sugar and 2,500 cedis for salt. So in this case, if you want to represent this in a form of table or in a tabular form, what you do is you have 1, 2, 3, 4, right? So you write 1,000, you write 3,000, you write 5,000, and you write 2,500, right? And so this is what the matrix, or yeah, there's the matrix. Do you get it? And so there's the function or the use of matrix. We represent the sales or the value in a tabular form. I hope you get that. So you can represent this by any letter. Let's say P equals this. And so this is the matrix. This is what we are going to deal with today. Okay. So we are saying the whole form is what? Matrix. If you have another form or tabular form like this, the two combine to give you what? Matrices. But the elements that are in the matrix, they are called what? Entries or elements. Entries or elements. You get it? So we are going to look at how to perform addition, subtraction, multiplication, and all that under matrices. So join me as we go through. So okay, let's begin with addition of matrices. But before then, let's look at the sizes. Let's look at the sizes of matrices. So the sizes talks about either the matrix is 2 by 1, 1 by 2, 2 by 2 matrix, 3 by 3 matrix, or you have 2 by 3, or you have 3 by 2. So we have different forms of what? Matrix. They are grouped according to what? The sizes. And so how do you then identify whether this matrix is what? 2 by 2, 2 by 3, or 3 by 2? So we are going to look at that. Suppose you have this 100, 20, 50, 70. Suppose you have this, right? So you know how to group what, or you know what a column and a row is. So this line represents what? A row. Any horizontal line represents what? A row. And any vertical line represents what? A column, right? So this is a row and this is what? Column. Okay. So from this matrix, you can say that you have one row like this. This is a row. Another row, right? So this is also a row. So all the horizontal part represents what? Rows. Then if you want to check out for the column, you see you have a vertical numbers like this. So you can say this is the first column. You have column 1, row 1, row 2, and you have another column, right? So you can say column 2. So you can clearly see that you have what, two rows and what, two columns. So we group them by saying we pronounce the row first. So we say 2 by what, 2. We pronounce the row first, so it becomes 2 rows by 2 columns. Do you get it? So this matrix is what, 2 by 2. Then if you have a matrix like this, it is what, you see, you have one row like this. So this row 1, this is what, row 2. Okay, then for column you only have what, one column. So you see column 1, that is it. You don't have any other column. You get it? So when you are pronouncing the size of this matrix, what you do is the row comes first, right? So it becomes 2 by 1 matrix. Okay, then let's also look at this one. If you have let's say if you have 2, 3, if you have this matrix, how do you also pronounce this matrix? You see, you only have what, one row, one horizontal numbers, right? So it becomes row 1. Then for column you have one number here, you have another number here, right? So column 1, you have column 2. Okay, so when you are pronouncing it, always what, the row comes first by the column. So we say 1 by what, 2. This column is what, 1 by 2. The same thing if you have 2, right, comma, 2, 3, 4, 6, 7, 5. If you have this matrix and you are being asked to mention or pronounce the size of this matrix, what you do is the row comes first. So you have row 1, row 2, row what, 3, right? Then for column you have what, the first column, that is column what, 1. You have column 2. So always the row comes first by the column. So you say what, 3 by 2. So this matrix is what, 3 by 2 matrix. And if you get a matrix like this, so this matrix is what, one row, another row, another row. So you have 3 rows, right? Then you come here, you have 1, you have 2, you have 3. So 3 rows, 3 columns, we say 3 by what, 3. So that is how we find the size of a matrix. Always the row comes first, then by what, the column. So the row is the horizontal part, by the column is what, the vertical part. Do you get it? So now let's move on to the addition and subtraction of what, matrices. Okay, and have it in mind, 3 by 3 2 by 2 matrix is also called what, a square matrix. Do you get it? It's a squared matrix because it has a squared shape. Okay, so now let's start with addition and subtraction of matrices. So this is addition and subtraction, addition and subtraction of matrices. Okay, yeah, so let's start. Addition and subtraction of matrices is very simple. That is the most easiest among the whole topic. Do you get it? Because here you are just going to do with the entries. You are going to match them. That is it. So suppose you have A, B, let me write it, B. Suppose you have what? A, B, C, D. So this is what, one matrix plus another matrix. You have E, F, G, H. So you have these two matrices, right? So addition this first number, or let's say the first letter here, will add towards the first letter in the other matrix. So you say A plus what? E. This one will add to this one. Then when you come to B, the B will also add to what? The F. So you are just matching them. Okay. So you bring it here. You say B plus F. Matrix, there shouldn't be any addition or something here, because you see there is what? Free spaces here, right? So you are treating them as it is. So C will also add to what? G. So C plus G. Then D will add to what? H. D plus H. The same thing. So after adding them, then you write what? Your total answer. Do you get it? The same thing applies to what? Subtraction. So when it comes to addition and subtraction of matrices, that is the easiest among the uh, other forms that consist of the operational signs. Okay, so now let's solve an example. Suppose you have 2, 5, 7, 3. You have this matrix plus 1, 4, 6, 3. You have this. So you have to what? Add these two matrices, right? So this is A, and this is normally A and B, right? So the question will ask you to calculate for the question will ask you to find A plus B, right? So if you see something like this, it means you are supposed to add this matrix plus what? This matrix. So this matrix is what? A. So we are going to add this to this one. So we have 2, 5, 7. You have the question already. So let me just do it straightforward. So now we say A plus B is equal to, this one will add to this one. So you have 2 plus 1. Then you shift because there is spaces here, right? So you move to your right hand side. 5 plus what? 4. So you have 5 plus 4. Okay. So this 7 will also add to what? This. So you have 7 plus 6. Okay. Then you have what? 3 plus 3. So 3 plus 3. Right. Okay. So now you do your final calculations. It implies that this whole matrix is equal to 2 plus 1 is what? 3. 5 plus 4 is what? 9. 7 plus 6 is what? 13. And 3 plus 3 is what? 6. Right. So this is your final what? Answer. And so anytime they ask you to calculate for any matrix, what you do is you just match them. Okay. You add them by matching each corresponding what? Entry or element. So you cannot add this 2 to this one. Sorry, this 2 to this 4. It's always what? The corresponding what? Entries. So this 2 matches to what? This matches to this. This also matches to this. This matches to this, and this matches to this. Okay, so that is it. Let's solve one question under subtraction. Okay, then we move on to the next one. But don't forget, I'll give you a question to try, and you provide me with the answers at the comment section. Okay, so you have this matrix which says you have 4 here, 5 here, you have 0 here, you have 1 here. Okay, minus, you have 2 here, you have 3 here, you have 1 here, you have 1 here. Okay, so this is S equals, and this is T equals. Okay, so find S plus T. Okay, so S plus T will be equal to, we say S plus T is equal to corresponding entries as usual. 4 plus what? 2. Sorry, it is, we are doing subtraction. So find S minus T rather instead of S plus T. Okay, yeah, so this is the correct one. So 4 minus what? 2. Okay, look, let me change one value here. This one is negative. Okay. Yeah. So s minus t is equal to 4 minus what 2. You have what 2. Okay. 0 minus 3 is what negative 3. So you write your negative 3 here. 5 minus what 1. So you know negative will change to what positive. So it becomes what positive 1. So 5 plus 1. Okay, because we say 5 minus 1 is 5 plus 1, which is 6. So we write our 6 here. And 1 minus 1 is what 0. So we bring out 0 here. This is our final answer for s minus what t. So when it comes to subtraction of matrix, this is how we also do it. Okay, so now I'm giving you 2 questions to try and you provide the answers at the comment section. Okay, so um, when you are providing the answers, please, you see matrix is in the form of 1 2 3 4. So if you are providing the answers, because you can't arrange them like this at the comment section, what I would like you to do for me is you write them the row first, the first row first. So 1 what 2. Okay, then you bring dash, you see 3 4. Okay, so that will be easy for me to interpret it. Do it this way for me. Okay, so you are 2. This is the, try this one. Just 2 questions. So addition and subtraction. So you have matrix m and n. So you have m equal to 2 negative 3 4 1. Okay, plus you have n equal to 1 negative 2 4 3. This is the first one. Then the second one is q equals q equals 4 7 2 9 minus, so this one you have to find m plus n. Okay, then this one, so normally I should even remove this. So normally it's comma, not the sign, it's comma here. Okay, yeah. So q equals this and your r equals to 6 5 4 0. Okay, so you have to find q minus r. Okay, so this is what you have to find. Okay, so you solve this one for me as we proceed to our next sub topic. So we are going to look at multiplication of matrices by a scalar. Multiplication of matrices by a scalar. Okay, so multiplication of matrices by a scalar. Okay, so there's the assignment. I'm cleaning it. So we all know scalar, right? So you know how to establish what your matrix, right? So after getting the matrix, what you would have to do is you multiply what the scalar given in the question by the matrix, and you are going to multiply the scalar by each entry or each element in the matrix. So suppose you have a equal to 2 4 1 6. So this is your what matrix, right? And you have been given a scalar. A scalar is normally represented by what k, right? To be 2. Okay, so what you are going to do here is you are going to use the 2 to multiply what the whole matrix here. So we say k multiplying what a is equal to this 2 will come here. You have 2, 4, 1, 6. So it implies that these 2 will multiply this to give you what? 2 times 2 is what? 4, right? 2 times 4 is what? 8, right? 2 times 1 is 2, and 2 times 6 is what? 12. So this is your final answer. You know how to do your simple multiplications and all that. So that is, you don't have to find it difficult. So you always multiply your scalar by what? The matrix. Okay, so that is it. Don't forget, scalar is always represented by what? K. Okay, it's always represented by K. And if you have a matrix A, B, C, D, this is the basic, or this is the rule. Do you get it? What you do is you multiply this K by this A to get what? K A. You multiply this K by B to get what? K B. And this one to get K C and K D. Right. So this is the answer. Okay, this should be your final answer as it is presented here. So it's very simple. You see that, right? So multiplication of matrices by scalar, that is it. You will always be given what? The scalar, either 2 or 3 or 4, whatever. All that you need to do is multiply it by the matrix and you are good to go. Okay, so let me give you one example, then we solve together. Right after that, I also give you another example to try it for me. Okay, so given that m equals 3514, it says given that m equals 1, 5, 3, 4. Okay, and n equals 2, 3, 1, 6. N equals 2, 3, 1, 6. It says find 2m, find 2m plus what? 3n. Okay, so this is solution. You see, this our m, this n, right? Now they have been provided us with what? The scalar, right? So we have 2 as the scalar multiplying what? This matrix m, and we also have what? 3 multiplying this matrix what? N. Okay, so what we are going to do is we are going to use 2 to multiply this, and so we have 2 equals, or 2 into 2 open brackets 1, 5, 3, 4, plus we have 3 into brackets, we have 2, 3, 1, 6. Okay, so this is what? 2m plus 3n equal to. All right, so let's proceed from here. Now we are going to expand the matrices. Okay, so 2 multiplying 1 will give you 2 times 1 is what? 2. 2 times 5 is what? 10, right? 2 times 3 is what? 6. And 2 times 4 is what? 8. Okay, plus 3 times 2 is what? 6, right? Sorry, 9. Which one? 3 times 2 is 6. Okay, then 3 times 3 is what? 9. 3 times 1 is 3, and 3 times what? 6 is 18. Okay, so now this is what we have. This matrix multiplying, adding what? This matrix. So we know how to perform what? The addition of matrices. So when you get here, you apply that. Okay, so now our final answer is what? 2 plus 6 is what? 8. We have 8 here. 10 plus 9 is what? 19. Okay, 6 plus 3 is what? 18. And 8 plus 18 is what? 26. Okay, so this is the final answer. Okay, so that is it. Anytime they give you this and ask you to find, they give you this and ask you to find something like this, you should know this what? These are scalars. So you have to use the scalar to multiply each matrix. And after multiplying them, you add them. Okay, the same thing applies to what? The subtraction of what? Matrices. Okay, so let me give you your question to try, and we proceed to the next one, that is multiplication of matrices. Okay, so um try this one. Try. Let me give you a question. Okay, given that m, so given that m equals 2 1 3 2 4 2 3 2 4 2. Okay, 3 2 4 2. Then you have n, right? So n equals 3 2 1 3 3 3. So find I. 4m minus 2n, and I. Find 2m plus 3n. Okay, so this is your question. Try this one. Okay, so now let's move on to the multiplication of matrices. Okay,